So our next speaker is Hallee Schearer, who is about to start her doctoral work at Northeastern University in Boston. She's going to be talking to us about very important sort of foundational questions about data reliability when you're using naturalistic conditions, and maybe a little bit about how much data you need to get reliability. So Hallee, take it away.
Thank you. Hello, I'm Hallee, as Tammy said. And I'm going to tell you about the topics of reliability and validity, how they're related, different influences on the test-retest reliability of fMRI data, how we study reliability, stimulus consistency and data amount, which are particularly specific to naturalistic neuroimaging here, and what we know so far about the reliability of naturalistic data. So first of all, we'll go over some definitions here. Reliability is very important in science, and it represents the consistency or reproducibility of a measurement across repeated observations. And this is very closely tied to the concept of validity, which is whether the measurement actually captures the intended construct, if it's actually measuring what you think it is. And together, these two concepts represent the extent to which a measurement can be used to produce meaningful and generalizable findings. So before we get into the movie-specific things, we are going to, I can't see my next slide, but I'm going to take a guess here. And yes, first of all, Dr. Noble is going to tell you a bit about different factors that influence the test-retest reliability of movie data. Of just fMRI data in general.
So first off, we know that a number of different acquisition factors can impact reliability. We especially know that more data per subject can improve test-retest reliability, although there are diminishing returns with more and more data. We also find that if you average data across longer intervals, let's say a month apart, that average measure tends to be more similar to other average measures within a couple of months, let's say. So in general, having data average across longer intervals tends to yield a more reliable long-term measure. In contrast, it seems a bit counterintuitive, but if you just have a few short scans that are next to each other, those will be really reliable one to the next. They might not necessarily generalize to longer time periods, but they will be really, really similar to each other, more similar than you collected at 1 month and then the next month. There are also a number of different population effects. So I was lucky to be part of a study led by Alex Dufford that showed that infant connectivity tends to be less reliable than young adult connectivity. There's also different literature that shows that older adult connectivity tends to be less reliable than young adult connectivity. So if you take that literature together, we see this inverted U-shape where young adults tend to be measured with better reliability than infants or older adults. There's also some mixed effects of different clinical groups. We tend to see that quite a few clinical groups show less reliability than typically developing groups. But I was also part of a cool study led by Chris Camp that showed that adolescents with depression tended to show higher reliability than typically developing adolescents. So there are some mixed results out there. There are different reliability, also different parts of the brain might be measured with different levels of reliability. In connectivity, those edges that are measured within network tend to show higher reliability than outside networks. Cortical areas tend to show higher reliability than subcortical areas. And there's also a relationship between reliability and effect size, although it's actually extremely small. And then there are a number of different types of behaviors that can impact reliability. But I'd say in general, the idea is if someone is awake and in the scanner doing especially some sort of task, so the more alert somebody is, the higher reliability we tend to record. And then finally, there are a number of analytical factors that can impact reliability. I like to highlight this idea that artifact regression tends to decrease reliability, but it's actually a very complicated issue where we also see some studies pointing out that you might have better findings, better ability to detect findings of interest when you use artifact regression, even though test-retest reliability decreases. So I think it's important to continue using artifact regression in order to better detect effects that you might care about. This is similar to a study that was done by Pervez and colleagues, which also showed that leaving artifacts in the data can result in better predictions, but they also don't recommend that you leave artifacts in the data. There are also a few other choices that can improve reliability, like not using task regression, using full correlation for connectivity estimation. But the one I like to highlight the most is that using multivariate measures tends to lead to much higher reliability than using univariate measures.
All right, we will get back to multivariate measures later, but for now we're going to move on to how we measure reliability. So just like with resting state, to measure the reliability of movie fMRI, we need two separate scans. And from those two scans, they're separated by an interscan interval, and from those we can estimate the within subject variance, the between subject variance, and then we combine those together in the intraclass correlation coefficient. And then this interclass correlation coefficient tells us what proportion of the variance comes from between subject differences relative to the total variance. And specific to movie fMRI, here we need to make an extra decision of whether we're going to show the same movie to everybody during the two scans or if we'll show different movies. And it's quite common in naturalistic studies to show different stimuli in the two movies, but there are some special considerations here that Dr. Xu was going to tell you about, but she lost her voice, so I am going to follow her script along here instead. So these are her slides. So if we have different stimuli or conditions in our two scans, we can merge them together to make this hybrid data. The question is, if we do that, does the reliability of that hybrid data depend more on the reliability of the two conditions that we're merging, or does it rely more on how similar the two stimuli are? It turns out that the reliability of the two scans matters more, and it has a positive relationship with the reliability of the hybrid data. On the other hand, the stimulus consistency doesn't seem to play a significant role here. However, this is not always the case. So if we have hybrid data from more different conditions, in this case 4 scans that are concatenated from different states, then stimulus consistency matters more than the reliability of each condition. So in this case, it's better to use more homogeneous stimulus scan conditions. Now, just like with resting state, it's really helpful to know how much data is enough data, and the more is better rule generally holds for movie fMRI as well. Typically, we consider 20 to 30 minutes of data necessary for individual FC to reach a stable plateau, and movie fMRI tends to provide higher reliability for both FC and dynamic features shown in the bottom left here. In fact, even short segments of movie watching can show higher reliability of FC than rest. So to collect this much data, should we collect one long continuous scan or collect multiple short scans and concatenate them together? This study, including Ting, showed that the total amount of data is, if the total amount of data is the same, say 15 minutes, then collecting multiple shorter scans and concatenating them tends to yield higher test-retest reliability. And this could be because even a brief break, like stopping the scanner for a few seconds, can help reduce head motion, especially in pediatric or clinical settings. So here's a little summary about what we know so far about the reliability of naturalistic data. When we have identical movies in the two scans, we see increased ICCs or increased reliability of FC with movies compared to rest. In a similar study that had 12 repeat viewings rather than just 2 of the same movie clip in a small sample, they found similar ICCs with movie compared to rest. And even when using different movies in the 2 runs, they still find similar ICCs of movie compared to rest. Now, those were all univariate using the interclass correlation coefficient, but there are also some multivariate measures that we can use to try to get at the reliability of patterns in this data. And we looked at this earlier this year and found that movie watching improved discriminability, which is one of those measures, in 1/4 of brain regions, improved the fingerprinting in 15% of regions in movies compared to rest. I'm happy to talk about the multivariate measures more later at the table if anyone's interested. And if you are interested in which regions those were that were improved with movies compared to rest, We have this web app that you can find at the QR code where you can scroll through all those regions and see which one's improved. So to summarize here, overall the data show that naturalistic conditions often improve the reliability of fMRI data relative to rest, but we still have many unanswered questions. I'm going to leave you with a few recommendations. First of all, most of the recommendations for improving reliability are the same for movie watching as they are for rest. So if you can collect longer scans, that'll improve the reliability. Healthy young adults will have better reliability, and cortical regions, etc. Also, we see that the benefits of movie watching for reliability are region dependent, and you can find those on the app. We recommend multiple short scans over one long scan. And when you are concatenating across many scans from varied stimuli, we recommend optimizing the homogeneity of stimuli and data. On that note, we would love to hear any other questions that you have or topics that you feel we missed. So come find the reliability table later, and I'm not sure if there's a survey. Is there a survey? If there's a survey, please fill it out, and you can also email us.
Awesome. Very nice. Okay, fantastic. So if you have burning reliability questions, or you're trying to figure out how long a scan or how to break it up or any of those sorts of things, you can go talk to Hallee later in the breakout session. Oh, we do have a question? I'm so excited. Please go ahead.
Yeah, I don't know if that's more a question for me or for Pete, getting at the ISCs as well, but the repeat movie viewing is a consideration with reliability as well, that if you watch the same movie for a second time, you are going to perceive it differently and your brain activity will be different. For those situations, we can consider also using like different episodes from the same TV show, for example. So you have a lot of things that are similar, like the same characters and movie style, and the reliability will probably be better than if you show completely different movie stimuli there. But as for the ISCs, I haven't used those that much, so I would refer that part onwards to our other subgroups. Yeah?
Hi, I have a question as well. Thank you very much to all of the speakers here. So you said shorter intervals with like breaks is better for reliability. And as an experimenter, I'm thinking, oh, great, then I can ask questions or do stuff, you know? But then what's short? Because you also lose things, right? You have this narrative arc that's building something that you're actually interested in. So how would you kind of go about this? What is a good short interval?
That's a great question. I don't know exactly how short. Like, I can't tell you a number of minutes or seconds, but maybe somebody else can. But I do think that we want it to be long enough that it's still more like a movie than it is a photo. If it's too short, then you're not getting like the narrative aspect of movies that we know are helpful, and you're not really sinking into the movie, and so your brain state's probably going to look less like movie watching. But maybe somebody else can give you a better idea, and maybe Dr. Shu or Dr. Noble can give you a better answer to that. So if you come find me afterwards, I will also ask them and get back to you.
Yeah, I think in that study by Ting, it's about, they're like 5 minutes is considered, that's about what those shorter blocks are. So 2 5-minutes were better than a 10-minute, right?
Right. Okay.
But no one's done the study to look at like, if we do 2 3 minutes, or if we do 2 6 minutes, like where are those magic points? Does it depend on what movie? Does it depend on your population? But yeah, around there, I would say. I don't know. Signe, do you have any? Or
Yeah,
Anna?
I don't know. Oh, okay, you can hear. In the HCP dataset, they did one run with several movie clips, and the interval between movie clips was rather short, 20 seconds. And one of the observations is that it might be a little bit too short because in those 20 seconds, the subjects, 20 seconds that are meant to be rest, in fact, the subjects are still processing the prior movie clip. So this complicates the analysis. So probably 20 seconds would be a minimum. You would want to go with intervals that are, somewhat longer than 20 seconds to kind of have a real break between movie clips.
Right. Thank you so much.
And the other thing is that
Very good.
next. You go next.